Our next entry is on reflections in the coordinate plane. So a reflection is a type of transformation that flips a figure over a given line. So if you think of a reflection like a mirror, whatever you see in the mirror is directly opposite from you. So if you put up your right hand, it's going to be on the right side of the mirror. If you put up your left hand, it's on the left side of the mirror. And we're going to use that strategy when we do reflections in the coordinate plane. Included in your package should be this handout for reflections. So we have figure PQRS. It's the same figure that we used for our translations when we slide the figure over. So what we're going to do is we're going to connect S and P and then shade in the figure so it's easier to see when we start reflecting it. For the most part, there's going to be two types of reflections you'll be asked to do. One is going to be over the x-axis, the other is going to be over the y-axis, and sometimes you'll be asked to do one after the other. But it's either going to be the x-axis or the y-axis. Once you get into Algebra 2 or possibly pre-calculus, they'll have you start reflecting images over a certain line, like the line y equals x, which is this line here, and they'll have you reflect it over that way. And so that's a different type of reflection with functions. We don't go over that in Algebra 1. It might be in exceeding expectations, so if you want to learn how to do that, I can show it to you individually, but it's not going to be part of this video. The first reflection we're going to do is going to be over the y-axis. And to show that, we're going to label it up here, over y-axis. What I want you to do is just kind of highlight this in blue. Blue is the color I'm using. If you use a different color, you highlight it in that color. Okay. And then to show we're going over the y-axis, you're also going to shade this y-axis in blue. Just so you can see that that is the y-axis that we're flipping it over. And now we want to come up with a general rule about how the coordinates change. So we have this table here, and so we start out with x and y, which is these coordinate pairs here for P, Q, R, and S, and we're going to write those in a second. But we want to do some experimenting, so we're going to flip this, right, reflect it over the y-axis, so it would be over here. And then we're going to see how the coordinates change and find some general pattern, if we can, about every time we flip it over the y-axis. So let's try doing that. Now I've copied down my coordinates for P, Q, R, and S. And what I'm going to do for reflections is I'm going to use my transparency paper, the one I use for translations, and I'm going to cut it so that I have just a fourth is all I need. Put that one aside for my next entry, and now I have some tracing that I can do. So I'm going to copy over PQRS, and when I do that, I want to label P, Q, R, and S. Just like so. So P, Q, R, and S. Now if I was translating it, I would be sliding it over. But that's not my goal. My goal is to reflect it over the y-axis. So I'm going to be flipping this. Now when I flip it, I want to be able to line it up exactly over that line of reflection. So I'm going to trace whatever the line is that they've asked you to reflect it over. So in this case it's the y-axis, so I'm going to trace the y-axis. And I also want to shade in or trace over the x-axis too, so that I can line everything up right in the center, so it's not like shifted above or below or a little bit to the right, a little bit to the left. So we want to match up everything with the line of reflection. And when we flip it, we're just literally taking this piece of paper and we're flipping it over and then matching up the lines of reflection again. And you can see, right, it looks opposite each other, like it's a mirrored reflection. And so now we have new points, and what we're going to do is we're just going to lift up our transparency paper and copy down where the point is. So this one's at 2, 1. That's there. And then I've got this one. And then right here. And then my last one right here. Now, the reason that we label these points is because it's not RQ going over to RQ. We've flipped it. And we want to show that, and so we don't confuse ourselves, we label our points because this is the new R called R prime. This is the new Q called Q prime. The new P, P prime, and then S prime. Okay, and what I'm going to do is I'm going to color this in, and to keep my color coding, I'm going to do it in blue. So I know that this is over the y-axis, this is the figure that went over the y-axis, this is the table that goes with that. So everything's nice and neatly color-coded. Now let's take a look at how the coordinates change. So P to P prime went from -2, 3 to +2, 3. The new Q is at 2, 1. The new R, 3, 1. And the new S is at 3, 5. So if we just focus in on the table that we just created, do you see a pattern when we flip over the y-axis between these xy pairs and then the corresponding xy pairs? So I want you to try and think about what that pattern is. So if we look at these x coordinates, now that you've thought about it for a little bit, okay, they go from negative to positive, negative to positive, negative to positive. Or if we were to take this figure and go the other way, it would go from positive to negative, positive to negative, positive to negative, right? So when we flip it over the y-axis, as a general rule, as we flip this over the y-axis, our coordinate pairs, which started out as x, y, go to -x, and the y stays the same. So my sign on x changes and the y stays the same. Which makes sense because when I look at the figure, I'm going from this side of the x-axis to this side of the x-axis, which separates it from negative to positive. So our next reflection is going to be over the x-axis. And for this one, we're going to use red. And I'm going to shade that in and just show that this is over x-axis. And then on my coordinate plane, I'll also shade this red to show that that's what I'm reflecting over. So everything's nice and color coordinated again. Now fortunately, when we start reflecting this, we can use our same transparency paper because we have the same figure. But now, instead of reflecting over the y-axis, we're going to flip it over the x-axis. So it flips down. And I would use the same strategy. I would move this paper. I know that that's my new Q. I do Q, and then because I already have a Q prime, I'd make it Q double prime. Now, I want to show you something else you can do if you don't have this transparency paper. So try thinking about a mirror. If you're 3 inches away from a mirror and it has your reflection, the person you're looking at, which is yourself, would also be 3 inches from the mirror. If you were 2 feet away, the person that you're looking at would be 2 feet away, because everything between you and the mirror is also being reflected. And it's the same strategy if we were to count. So if you notice, this P here is 2 coordinates, or 2 units away from the y-axis. The new P is also 2 units away. Same thing with Q, it's 2 away, 2 away, right? The S is 3 away, 3 away. So one way to do it if you don't have transparency paper is to just count. So that's what we'll do here. Of course you can use a transparency paper if that makes it easier, but counting also works too, and I want to show you every strategy that I can. So the R is 1 away from the line of reflection, so it's going to be 1 away on the opposite side too. The P is 1, 2, 3 away, so 1, 2, 3 away. Here would be the new P. So I have P, Q, and R, and now the last one is S. The S is 1, 2, 3, 4, 5 away, so it's 1, 2, 3, 4, 5 away. And there's the new S. And now I should have my figure, and I'm going to trace it in red. Just to keep things color coded. And that strategy should have worked if I put this over. Either way, it would have gotten me the same figure. So by counting or by flipping. It's just very important when you start moving things over that you know which point corresponds to which point. It's easier with this one because it's a very distinct figure, but if you were to say flip a square, that's when it can start to get really confusing about which points go where. So make sure you label correctly. And let's look at how those coordinates change. So we started with the original PQRS. So all I did was copy the ones that I had already written down here. And now let's see how they change when I go to the x-axis. So P went from -2, 3, and it's now at -2, -3. Q is at -2, -1. R is at -3, -1. And the new S is at -3, -5. And so again, we're looking at a pattern. The pattern we had for the y-axis was that the sign on X changes. And we look over the x-axis, the sign on the Y changes. So that's our pattern here, and we're going to fill that into our table. When we have original XY points, the sign on the X stays the same, but the sign on the Y changes. Now it's really, really important that you understand this part here. Just because this says -y doesn't mean it's always a negative number. It just means that you're taking the original y and you're changing its sign. It's like multiplying something by -1. If it started as a negative, it's going to become a positive. If it started as a positive, it's going to become a negative. So if we were to estimate what happens if we do both at once, let's take a look. So we've got it flipped over the x-axis, and then we flip it over the y-axis. If we were to take a look at our coordinate plane, we have our transparency paper. Let's say first I flip over x, so the y changes sign, and then I flip over the y, and the x changes sign. So really from going here to here, everything changes its sign. So we don't really even have to do this one, this reflection. We're just going to state that when you do both at once, both the x and the y will change sign. Now let's take a look at how the coordinates change. So p to p prime went from negative 2, 3 to positive 2, 3. The new q is at 2, 1. The new r, 3, 1. And the new s is at 3, 5. So if we just focus in on the table that we just created, do you see a pattern when we flip over the y-axis between these xy pairs and then the corresponding xy pairs? So I want you to try and think about what that pattern is. Okay. So if we look at these x coordinates, now that you've thought about it for a little bit, okay, they go from negative to positive, negative to positive, negative to positive. Or if we were to take this figure and go the other way, it would go from positive to negative, positive to negative, positive to negative, right? So when we flip it over the y-axis, as a general rule, as we flip this over the y-axis, our coordinate pairs, which started out as x, y, go to negative x, and the y stays the same. So my sign on x changes and the y stays the same. Which makes sense because when I look at the figure, I'm going from this side of the x-axis to this side of the x-axis.